All right, so I had some technical difficulties earlier, so I thought I would re-record these notes so that hopefully it makes more sense without me on the verge of tears, you know. So actually, I'm going to go back really quick and look at the blue sheet, just with the identifications or the definitions. Parker, say hi real quick.
Hi.
All right, I'm going to record something, so give me a couple of minutes, okay? So we can see we have our sine, cosine, and tangent. Those are our three trig ratios or ratios for triangles. In your calculator, you'll find them as SIN, COS, and TAN. So you're still going to hear me say sine, even though it looks like sin. I'll still say cosine, even though it looks like cos or cos. And I'll still say tangent, even though it looks like tan. So just as a quick review, the sine is going to be your opposite over the hypotenuse in a triangle, which looks like O over H. The tangent or the cosine is going to look like the adjacent, which just means next to, over the hypotenuse, which looks like A over H. And our tangent, which is the one we use rise over run, is our opposite over the adjacent leg, which looks like O over A. Okay, so thinking about that, and you could go back and pause that if you needed to write those down. We'll come in and do some more of the blue sheet in just a little bit with the um, examples on the notes too. So that way we can do them all at the same time. So it says, with your study team, look through all your triangles and decide which methods work the best. The triangles are not drawn to scale, so they could look off a little bit, and that's okay. So on this first triangle, the biggest thing with sine, cosine, and tangent, you have to start with your angle. And I'll even make that little note here. Always start with the angle. Because from there, that's how you're going to identify your opposite, adjacent, or hypotenuse. So from our angle, we can see that we have the opposite would be x, and in this triangle, our hypotenuse is our 19. So since we have O over H, that means we're dealing with sine. So I'm going to write the equation sine of 28 equals x over 19. And so then I can plop that over 1, and I can just do my cross multiplying. I can type in my calculator the sine of 28. So you'll see, so if you're typing it in, sine of 28 is going to give me about, I'm going to try to get my stuff lined up here. Oh, you guys can't probably see that. There we go. 4694, or round that up to a 5. So 0.4695 equals x over 19. And here now we can just multiply. Now you can just type in your calculator, sine of 28 times 19. Your calculator is smart and it can calculate those decimals without having to get the decimal first. So it's fine. It can do multiple operations at the same time. So if I do this though, I'm just going to multiply 19 times this decimal. And actually I'll bring up a calculator on my screen here so that you guys can see that. Oops, not that calculator. Let me grab the scientific calculator. Maybe. There it is. So I'll bring that over here. That way you guys can see how to do these on this calculator too. I'm going to hide my tools. So I'm going to do my sine of 28, and I'm going to multiply with that 19. And it gives me about 8.92. It is what it'll round up to. If we just did that with the decimal, if I did my 0.46695 times my 19, it already puts me at the 8.92. So it's just a slightly different version. Okay, on the second triangle, we can see here we have two sides. We have our opposite and adjacent. However, I know that this angle is my 45-degree angle. And since it's a 45-degree triangle, I know that the legs are equal. We worked with that a lot last chapter. So that means that x has to just be 8. So that one's a real quick, easy one. On our next picture, my angle is 61 degrees. There is nothing opposite. There's no opposite here. So I'm not going to use sine, cosine, or cosine. No, I'm sorry. I'm not going to use sine. There we go. Because there's no opposite. Sine uses opposite over hypotenuse. Instead, I have the adjacent and the hypotenuse. So if I have a and h, that's going to tell me to use cosine. So I'm going to do cosine of 61 equals adjacent, because that has to go on top. So I'm going to put 18 over x. Here again, I'm going to put a 1 on the bottom, and I can cross multiply. If I do that, I have to do x times the cosine of 61, and this is where it might be helpful. What do I have open? Oh, I can close that. Sorry, I had some stuff open from a different class. This is where it might be helpful to get your decimal, because you guys aren't as familiar with cross multiplying yet with these crazy numbers. So cosine of 61 is oops, I lost it, 48 something. Nope, that's still not it. 4848. All right. Equals 18. And then we would have to divide to get x by itself. So we'd have to divide by that decimal. And the reason we do that, part of the reason we're going to divide by that decimal, is because the hypotenuse should be the biggest side. So if I do 18 divided by 0.4848, I get a larger number, which is what should happen because our hypotenuse should be the biggest side of that triangle. So I've got 37.13. Okay, so if you're trying to find the hypotenuse, you're probably going to have to divide by a decimal in order to get that hypotenuse to be a bigger side. On the next one here, my angle is 25 degrees. So my opposite is my 6, and that means my hypotenuse this time, or my x is my hypotenuse. So here again, I'm working with O and H, which means I'm doing a sine problem. So I'm going to do sine of the angle. The angle always goes there. Opposite is my 6, and my hypotenuse is x. So here again, I know that I'm going to have to divide because I'm looking for my hypotenuse. So I'm going to end up doing 6 divided by whatever the decimal is. So 6 divided by, clear all this out. I've got to figure out my sine of 25, which gives me about 0.4226. And I know I'm going to have to divide after I do all my cross multiplying and everything. So I'm going to type that into my calculator. Here again, you could just divide by the sine of 25. I'm going to show you first 4226, and I get about 14.19. If I just typed in 6 divided by the sine of 25, look at that. I get basically the same exact numbers. Okay. It's only after a couple of decimal points that they start getting thrown off a little bit. So basically this will round up to 14.2. Okay. On the next one, more of the same. The more you do these, the easier they're going to get. Just try to draw some lines in here real quick. So here I have my angle. There is, again, no opposite this time, so I'm not going to use sine. I do have an adjacent side, and I have a hypotenuse. So here again, I'm going to use, so I have a over h, so that's going to tell me to use cosine. So I'm going to write cosine of my angle equals the adjacent over the hypotenuse. I'm going to figure out what the cosine of 60 is, and I'm going to divide, because I have x on the bottom, I'm going to have to do, all right, so I have cosine of 60, which is actually just 0.5. That's handy. And since x is on the bottom, I'm going to have to do 8 divided by the cosine of 60. Or I could write 8 divided by cosine 60 using the actual tangent ratio itself, or not tangent, trigonometric ratio. And either way, I get the exact same answer because 0.5 is a nice precise decimal. So I get 16. So I'm going to write this as 8 divided by 0.5, which just gives me 16 for my solution. Move myself over there. So on part F, here's my angle. I do have an opposite, and I have a hypotenuse again. So OH, I keep doing these over and over. OH is just telling us to use the sine ratio. So sine of 30 equals the opposite over the hypotenuse. Now my hypotenuse, or my side that I'm looking for, is on top, which means I am going to be able to just do a quick cross multiply problem. I just need to figure out what the sine of 30 is, and I'll multiply that. So sine of 30, oh, look at that, I get 0.5 again. So I'm really just going to multiply 42 times 0.5, which tells me that x is going to be 21. Here I know that that side has to be smaller than 42, smaller than the hypotenuse. So that kind of gives me a little guarantee that I did my answers correctly. On the next one, I have a 0-degree angle. Guess what? Whether I do sine, cosine, or tangent, oops, let me get my calculator here again. If I was doing sine of 0, I get 0. If I do cosine of 0, well, that gives me 1. And if I do tangent of 0, I get 0. So what we need to figure out, what do I have? So here's my angle. This is my opposite. This is my adjacent. There's no hypotenuse. So that means I would be dealing with a tangent. And we remember, or we saw, that in tangent, if I typed in tangent of 0, I get 0. So really, technically, x would be 0, but in fact, it's not really possible to have a 0-degree angle anyways. All right. How about a 73-degree angle? We can have one of those. Here again, we have no opposite. So I have two other sides. I have an adjacent side and I have a hypotenuse. So A over H tells us we're going to do cosine. So we're going to write our equation cosine of 73 equals x over 3. Plop that bad boy over 1. I got to figure out what my decimal is for cosine of 73, which gives me about 0.2924, 2924. And I'm going to multiply that. Parker, please stop. I'm going to multiply that in my calculator either 3 times the decimal, so 3 times my 0.2924, or I could do just 3 times my cosine of 73. Oops, not 7 minus 73. And look at that, I get the same 877, 877, so probably about 877. Or you could round it up to 88 if you want. The more you do these, the easier they get. Figuring out where your opposite is, there's no hypotenuse on this problem, which means that 12 is our adjacent. So if we're doing O over A, that's a tangent problem. So we're going to write tangent of 42 equals the opposite over the adjacent, because that's exactly how it works every single time. We'll cross multiply. So really I'm doing 12 times the tangent of 42, or 12 times whatever the decimal is for tangent of 42. So 0.9, basically 9004. So I could do 12 times 0.9 0.0004. The more decimals you have, the more precise it's going to be. Or I could do 12 times the tangent of 42, which still gives me 10.8. Okay. So now that we've done a bunch of those, let's take a look. So we've been working kind of towards this idea. We have this woman, or person, Marta, arrived for her geometry test only to find that she had forgotten her calculator. She decided to complete as much of the problems as possible, even and showing her work, showing her steps. So we see here she started with sine of 25 equals 29. Sine of 25 equals 29. Oops, that's not what I wanted. Let me try that again. That's what I wanted. So she's got 29 over x. So we can see she started with her angle. She labeled her 29 as the opposite and the x as the hypotenuse. She's using sine as her equation because she has O over h. So then what did she do? We can see kind of like how we've done, which she plopped that over 1, so she just cross multiplied. And to get x by itself, then she's divided to get x by itself. Okay. So Marta's answer is called the exact answer. That's kind of what we've been working towards. So if we use our calculator, we could type that in. 29 divided, oops, clear. Try that again. 29 divided by the sine of 25. And we get about 68.62 if we round that. Whoa. What just happened? Why did my computer... That's weird. I don't know why I did that. That was weird. Oh, what did I... I forgot what I said. 68.62. Okay. So then let's try a couple more of those real quick. So now we have another problem. We have 53 degrees. We can see we have the opposite. There is no hypotenuse, which means that 5 has to be our adjacent. So if we are using opposite and adjacent, that makes this a tangent problem. So we're going to write our equation tangent of 53 equals our opposite on top and our adjacent, the 5 on the bottom. If we were to try and solve this, we would crisscross applesauce. So y would equal 5 times the tangent of 53. So that's our exact answer. So then we would just type that into our calculator. 5 times the tangent of 53. So we get about 6.64. There we go. So then the last ones, maybe using our trig table from chapter 4 might be helpful. I'm going to find that in here somewhere, maybe. Maybe. Oh, you know what? There, I can use that. So my trig table, this, let's see here. There we go. This thing right here. So if I use that, I'm going to grab it and pull that little bit right there. Okay, close that down, close that down. Whoa, that's really big. There we go. Make that a little easier to find. All right, so looking at these, I've got a 9 over a 9 for my angle. So these are all tangent, or this is a tangent problem because I have my opposite and my adjacent. So my ratio right now is 9 divided by 9, which would give me 1. So when I look at my ratio, at these on the side, we can see we have one problem where the ratio is 1, which means that our angle is a 45-degree angle. On the next one, here again, I have my opposite and adjacent, which means it's a tangent ratio, 1/5, and I can see there's my ratio, which means that I have an 11-degree angle. Oops. Trying to figure out how I can grab these couple of things without it making me. My computer is being kind of a brat right now. That's cool. Okay, so last one, I have my adjacent and my hypotenuse. We don't have, so that would be 5 over 10, which is 1/2, and that is not in the table. It's also not a tangent ratio, which means it wouldn't be in the table either. So we're going to talk about this one in just a little bit. I'm going to stop this for just a second. These are the end of the 512 notes. And I'll pick back up in 2 minutes here with the 513 notes. If I can find it.